This is AQA A-Level Chemistry. It's a multiple choice question on the topic of bonding. I'm going to recommend you pause, have a go, and then review. So what we're essentially looking at here is A, do you know the different shapes of molecules, and do you know the bond angles that we associate with them? So for example, CH4, I am hoping is going to stand out to you as being probably the first tetrahedral structure that you drew, and the one that you most commonly refer back to. That has a bond angle of 109.5 degrees, or there are bond angles between all four of the CH bonds, 4 bonding pairs and no lone pairs. In NH4, we have got we've got one nitrogen forming 3 bonds with H's, 3 covalent bonds, but its lone pair forms a dative covalent bond with a 4th hydrogen. So actually that one is tetrahedral as well, and actually that 109.5 should be up there. Taking us down to AlCl4-, well, Al can form 3 AlCl bonds with its 3 electrons, but the 4th Cl forms a dative covalent bond and comes in, making 4 bonding pairs. So we can see the 3 with the 109.5 degrees in the correct position are all tetrahedral. But now let's actually prove that ClF4- does have at least one bond angle of 90. Chlorine will form 4 ClF bonds. It's got a bonding pair, a bonding pair, a bonding pair, and a bonding pair. Chlorine has 3 more electrons left. There's 1 and 2 in a pair, and there's 1 more. But overall it's minus, so there's 1 more electron. So I've actually got 4 bonding pairs, and I've got 2 lone pairs. That's 6 pairs of electrons in total. That means that we have got a shape that's based on octahedral. And if it's based on octahedral, it's going to look like this, with the lone pairs going as far apart as they can. Now, generally, we talk about a lone pair reducing bond angles by 2.5 degrees. But because I've got one above and one below, and they're both having an equal influence on the ClF bonds, it means in this very specific case, there is no distortion. The bond angle is 90 degrees, so the correct answer is C.